Hi everyone. In our video today, we're going to talk about graphing linear inequalities. Okay, and so I'm on page 199 of the binder. So if you guys could pause and get to that page, and when you're there, you'll see towards the bottom kind of an example of what eventually we're going to get to. Okay, so in this box at the bottom of the page, it gives you an example. Y is greater than 4x minus 3. So these problems are really straightforward. You're going to graph the boundary line just like you would graph a regular equation. So y-intercept of negative 3, slope is positive 4. So you go down to that y-intercept of negative 3 and then up 4 over 1. Okay, but you might be wondering, why is it dotted? Well, the reason it's dotted is because, or dashed, because it's just less than or greater than. In this case, it's just greater than. So what we're signifying is that the solutions are not part, the points on the line are not solutions, okay? And then what we do is we test a point that's not on the line. So we test like the point 0, 0, okay? And you plug it in. So we say 0 is greater than 4 times 0 minus 3. And that gives us the solution 0 is greater than negative 3. That's a true statement. And so that means 0, 0 is a solution, but it also means every single other point on that side of the line, the boundary, is a solution. So we shade in all those points to signify that no matter which point I would pick, it would always work on this side of the line. All right, so a little above this, let's go ahead and look at example 2 here. So it says determine whether the coordinates are solutions to the given inequality. And testing a point out is something that's going to be really important. So let's take a look here. In part A, it says x minus 3y is greater or less than or equal to 6. So I need to plug in the point 0, 0. That's x, y. So for x, I'm going to plug in 0, and for y, I'm going to plug in 0 is less than or equal to 6. And we're seeing, okay, well, 0 minus 0. 0 is less than or equal to 6. So my answer is yes, that is a solution. Okay, because this is a true statement. 0 is less than 6. So the answer is yes. Okay. Then when we look at part B, y is greater than 2x minus 5. We'll call these x and y. So we get 4 is greater than 2 times 1 minus 5. So that's 4 is greater than 2 minus 5 is negative 3. That's another true statement. 4 is bigger than negative 3. The alligator's eating the correct number. So that's true. When it's true, we say yes, that is a solution. Okay, let's look at part C. Part C says x is greater than or equal to 2. Well, in this case, the inequality only involves x, so I'll take that x number 3. 3 is greater than or equal to 2. That is true as well. So far, true. So far, all of these are true, which means all those points are solutions. Let's finally go to part D here, and when we look at part D, this one only involves y, so it says y is less than 5, so I'm going to plug in the y value, and we'll get 5 is less than 5. That one's actually not true. 5 is not less than 5, so that's false, which means this is not a solution. All right, so let's turn the page to page 200 and do a couple examples. All right, on this page, we've got, let's look at example A. So it says, graph each linear inequality. And part A here says y is less than or equal to 1/2 x minus 4. Okay, so one of the rules we need to know is that when it's less than or equal to, or greater than or equal to, we draw a solid boundary line. Okay, and then when it's just less than or just greater than, we draw a dashed or a dotted boundary line. Okay, so in this case, we're going to draw a solid one. I'm going to go ahead and go to my y-intercept of negative 4, and go up 1 over 2, up 1 over 2, down 1, back 2, and then a solid line, so I'll draw that. Okay, the next thing I need to do is test a point. Okay, so I'm going to test point 0, 0. You can always use 0, 0 as long as it's not on the line. Okay, so we'll use the point 0, 0. And so I plug in 0 for y is less than 1/2 times 0 minus 4. Well, half times 0 is 0 minus 4, so this says 0 is less than negative 4. That's false. So what that means is that 0, 0 is on the wrong side of the line. So I'm not going to shade that. I'm going to shade below the line, the opposite side. So I shade down there. And that shading represents all the solutions to this inequality. Every point down in that shaded section down here will make this inequality true. Okay? All right, let's look at example B. In example B here, now it's not solved for y, so I'm going to do that first. Subtract 2x from both sides, and we get y equals negative 2x. Oops, not equals though. Y is greater than, start over, y is greater than negative 2x plus 3. Okay, so graph that, go to a y-intercept of 3, and then down 2 over 1. Alright, this one is just greater, so I'm going to make it a dashed line. Okay, so I do my dashed line there, looks good. And now I have to do a test point. So you ask yourself, can I do 0, 0? It's not on the line, so we can. So we test 0, 0. And so I get 0 is bigger than negative 2x, or negative 2 times 0, plus 3. That means 0 is bigger than 3. That's false also. Okay. So when it's false, that means I'm on the wrong side of the line, so I shade the other side of the line. Okay, and that's my answer. That graph with the dashed line and the shading represents my answer because those are all the solutions to the inequality. All right, example C. In example C here, I have to again solve for y, and this time when I divide by negative 3, I have to remember back in chapter 2, gotta flip the sign. So we get y is less than negative 2x minus 3. Y is less than negative 2x minus 3. Go ahead and graph it with a dashed line. Alright, with a slope of negative 2 and a y-intercept of negative 3. So we'll go down, the y-intercept is negative 3. Here's my slope of negative 2. And this will be a dashed line. Okay. And we'll test a point again. We can do 0, 0 since it's not on the line. And then we get the inequality 0 is less than negative 2 times 0 is 0 minus 3. 0 is less than negative 3. That's false, once again. So I'm on the wrong side when I do 0, 0. So I graph the other side of the line, or shade, the other side of the line that 0, 0 is not on. All right, and finally, example D. In this case, it says x is greater than or equal to negative 2. Okay, there's no y, it's just x. So back in the day, we used to graph this by making a little table, x, y. We get to say x is always negative 2 and y is any number we want. So when I go graph this, I get negative 2, 0, negative 2, 3. Oh yeah, it's a vertical line. This one's going to be solid because it's x is greater than or equal to negative 2. So I draw a solid line here. Right? But I still have to shade because it's an inequality. So the point that I can test, again, I'll test 0, 0. All right, and then really this one just says 0 is bigger than negative 2. That's true. 0 is bigger than negative 2. So now I'm on the right side. Okay, so I will, or the correct side, which happens to be the right side. So I shade the side of the line that 0, 0 is on, and there's my answer. All right, finally, let's take a quick look at example 4. So we get these two problems where the graph is given to us and we have to write the equation, or the inequality. Okay, so what we're going to do here is say that I know my slope is up 2 over 3, so my slope is 2/3. My y-intercept is 1, 2, 3, 4, positive 4, so 0, 4. Alright, so I know I could write y equals 2/3 x plus 4, but now I need to make sure that the shading is above, because that's where the shading is located. So when you have it in slope-intercept form, you can just talk about above or below. So since this point is, the shading is above, we want to shade value, we want to make it so that y is greater than or equal to 2/3 x plus 4. Okay, greater than because the y values where we shaded are bigger than the y-intercept. All right, finally in the second problem here, we have a dashed line, but we're going to use point slope form. Okay, so let's do a slope here of -1, 2, comma, or over 3, so -2/3. And my point, I'm going to pick this one here, which is 2, comma, -4. All right, so to do my inequality, I really need to figure out what inequality symbol will make this true. So I'm going to start by writing the point slope form, but with like a blank space for the inequality symbol. Okay, so this is going to be y plus 4, and then we don't know, equals, but some symbol there, -2/3, it's a negative, x minus 2. Okay. Alright, so now in order to figure out what the symbol is, I do a test. Alright, I can still test the point 0, 0, but in this case, I know this point 0, 0 should be false because it's not shaded. So when I test 0, 0, let's see what happens. I get 0 plus 4, 0 plus 4, some symbol, -2/3, 0 minus 2. Alright, so that's 4, some symbol, and then -2/3 times -2 would be +4/3. Okay, I want this to be false. So let's put the symbol in here that makes it false. The symbol that would make it false would be less than. So now I know that my correct symbol for my inequality is less than. So my final answer here is y plus 4 is less than -2/3 x minus 2. And we're all done. Alright, thank you for watching.